Hello everybody, and today we are going to be taking a look at the periodic table of elements. So let's start with the basics. There are 118 elements on the periodic table. And just so you know, from Americium down 95 to 118, they are all main labs, and they exist for less than a second. Maybe even less than that, or maybe more. It depends on what element it is. So there have been new elements added recently. I don't know which ones, but I know there have been recent ones. So let's start with some of the other basics. There are 8 groups on the periodic table. There are alkali metals, alkali earth metals, lanthanoids, actinoids, transition metals, poor metals, other nonmetals, noble gases. These are the elements of the periodic. So these are the groups of elements. So this is all color coded. So we have the color black is for a solid, the color blue is for a liquid, the color color red is for a gas, and the color green or grayish is for we do not know the state of matter. Like I said, americium will from Rutherfordium down to Unanoctium. They're all we don't know their states of matter because they haven't even been in existence for more than a second. So yeah, I just have a little picture of the periodic table that I'm going off of. So now I'm gonna give you an example of an atom. I'm just gonna use hydrogen in this case. We're gonna go to Google Paint, or Paint, I guess, Microsoft Paint. So I'm going to make the nucleus a yellow orb. This is just a very bad example of what this looks like. Okay, so this is hydrogen. That's the axis that it spins on, and here we have an electron. This is an example of an atom of, well, hydrogen. And yes, I may have misspelled this, but I don't know. So this is an atom of hydrogen. I'm going to write that down. Atom of, I'm going to redo this. Atom of hydrogen. So this, I'm going to label this. This is what it would look like. This is an electron. This is a nucleus. And this is the axis that the electron spins in. But really, it's more of a shape like this. Say if I do an actual more realistic version of this, this is a better orbit. It goes boom, 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 boom. There's a very complicated orbit for some of these, but some of them are more easy to tell, such as this. This is just a more derpy version and less complicated version. Easier to explain also. So, back to the periodic table picture. So here we have these would be the lanthanoids and the actinoids, and these fit into the transition metal and poor metal end section like that. This is white, and that doesn't have a group. I think it's none of the above. And this is unknown, but it's in the noble gases section, poor metals, it's like that. So yes, I'm not at my main house of recording. So yeah. And by the way, I have another channel, but I'm not going to put a link in the description because it's really not going to help. Okay. So let's get back to the actual element description. Right here, if you look where my cursor is, it says the atomic number, and it gradually gains 1 each time. That's how many elements there are. Then the symbol for the element, H for hydrogen, like some of them don't make sense. Like potassium is K. What else? AU is gold. Fe is iron. Cu is copper. What else? I'm trying to look for some examples. There's not really a lot, but some of them don't make any sense whatsoever. So here we have then we have the atomic mass would be down here where my cursor is. This is she's using beryllium as an example. This is its atomic mass, 9.012182. Then the name of the actual thing under the symbol, beryllium says right there. So it's easy to read. And this, I'm pretty sure it's what it's made of. Or what atoms or what things are linked together to make it. 224, see that? 28. Yeah, see, this is how, if you notice that these numbers added together actually makes this number. The atomic number is decided by these, like 2 plus 8 is 10, plus 9 is 19, plus 2 is 21. Let's do it with titanium. 2 plus 10 is 12, plus 8 is 20, plus 2 is 22. See? So the atomic number is most of the time decided by these. I'm not sure if all of it is, but I know most of it is. And if you see in this row, in these, this goes up. Well, this goes up by the little one right here. The 10 my cursor is on goes up and down here, and then 9, 10, 11. So it does change definitely. The build up. I'm pretty sure these are the atoms connected together to make the element. Like, say, let's go to helium over here. 2. It's its own element. But what if we go over to the less simple ones? Lithium, hydrogen, and helium make lithium. I think that's how it works. I'm not sure, but I think. I don't want to be misleading, but it would make sense. Okay. So let's get into some of the other things about the periodic table. What's inside of the nucleus? What is a nucleus? Well, a nucleus, if I can just, how do I do this? If I can open up another one, a nucleus is represented by this in my painting, but really, it's made up. This is going to be a proton, and black's just going to be blue's going to be a neutron. Okay, a proton and a neutron, these two together these two things are in the nucleus. So let's just represent this by that. So these two decide what an element is too. So if I'm just going to draw an atom of, I'm going to use a darker blue for an electron, an atom of hydrogen. This is not correct, but there could be five protons and, 5 protons and 5 neutrons. But it really does depend on the element. And yes, so that's going to be the end of this video. I hope you enjoyed. First video on my new channel, The Science Man. Please like, subscribe, show your friends. I hope you learned something today, and I hope you enjoyed. Have a good day.